So for example number 6, it says assume the International Space Station, which is 108 meters long and 73 meters wide, is in a 400 kilometer low Earth orbit. If the communication antennas have a 0.001 degree pointing error, how many meters off will the communications link be? Oh, wow. So we've got this International Space Station floating up here, and then we have Earth. Earth is like way down here. Okay, that's Earth. And the distance. So this is the I think we know that the distance from Earth to this thing is 400 kilometers. And they're saying that you're going to draw, and this is not to scale, but they're saying that this angle here is 0.001 degrees. And really what they want to know is how far off is it. They really want to know what is the opposite length. This is the hypotenuse. And then this would be the adjacent. So we're going to take the inverse of tangent of the opposite, which we don't know. Oh, wait. We want to solve for the opposite. Actually, I should probably look this up in the book. I'm pretty sure that's what we would do. Let me double check and make sure, though. Yeah, it says how many meters off will it? Yeah. So I'm almost 100% certain that's what we would do. Well, let's proceed. So now to find this, I'm just going to say that the tangent of theta is equal to the opposite over the adjacent. Okay. And so then tangent of 0.001 degrees is equal to O over 400 kilometers. So then I'm going to multiply 400 kilometers by the tangent of 0.001, and that'll give me the length of the opposite side. So let's just do that. So I'm going to say 400, oops, let's clear this out. 400, oops, why does it keep doing that? 400 times the tangent of 0.001. And so that would be 0.0069 kilometers. So it would be 0.0669813. Now, the other thing we got to remember is that if you wanted to change that to meters, you move the decimal 3 spaces. So I go 1, 2, 3. So it'd be 6.98 meters. And I'm pretty sure that's the answer. I'm just going to verify in my handy-dandy fancy teacher textbook and make sure I did the problem right. Usually I do. That would be embarrassing if I did it wrong. What example is this? 6? Oh, I'm good. Although they've got a slightly different. Oh, they did one. Okay, no, I did it right. I did it right. The one in the textbook is worded slightly different. Okay. Okay. So that's what it would be off. So what they're trying to say is that you might not be able to communicate to the satellite. This is, and so I did the math right. What they're trying to say is, like, if it's off by 6.9 meters, will they not be able to communicate with the International Space Station? And the answer is no, because it's 73 meters wide and it's 108 meters long. So there's a very high probability that they can target it and receive the messages back and forth. Does that make sense? Now, if this number was bigger, if this number right here was bigger than 73 or bigger than 108 meters, then they'd have to really find